Think about the last meal you ate. Maybe it was warm. Maybe it was soft enough to barely chew. You probably didn't think twice about it. But what if that meal was the reason you can think at all? It sounds strange. A plate of food shaping the very organ that lets you ask the question. But the real answer is far stranger than you expect. For most of your evolutionary history, your ancestors ate like every other animal on the planet, raw, tough, barely digestible, roots pulled from hard soil, meat torn straight from a carcass, leaves that took hours of grinding between the teeth just to break down enough to swallow. Now picture spending nearly half your waking day just chewing. That's not an exaggeration. Chimpanzees, your closest living relatives, spend around 6 hours a day chewing raw food. 6 hours, just to get enough calories to survive until tomorrow. Your ancestors were built for that kind of labor. Bigger jaws, bigger teeth, a gut that was long and complex enough to slowly break down tough, fibrous food. Every part of the body was tuned to one problem. Raw food gives you very little energy, and you have to work brutally hard to extract what's there. Then something changed. Somewhere between 1 and 2 million years ago, a strange behavior started spreading through small bands of early humans. They began putting food into fire. It seems almost too simple to matter. Heat touching flesh, heat touching root vegetables. But according to primatologist Richard Wrangham, this single habit may be the most important event in the story of what eventually became you. Wrangham calls it the cooking hypothesis. His argument is direct. Cooking doesn't just make food taste better, it pre-digests it. Heat breaks down tough proteins, it ruptures starch molecules, it softens plant fibers that would otherwise demand hours of chewing and grinding just to release a fraction of their calories. Suddenly, a meal that once required 6 hours of chewing could be eaten in under an hour. And the body no longer needed to spend enormous amounts of energy digesting it either, because cooking had already done half the work. So where did all that saved energy go? This is where the story turns from strange to almost unbelievable. Your brain is an extraordinarily expensive organ. At rest, it burns roughly 20% of your body's total energy, despite making up only about 2% of your body weight. No other primate spends anywhere near that much on their brain. For an animal living on raw food, affording an organ like that would be almost impossible. There simply isn't enough spare energy lying around. But cooked food changes the math entirely. Researcher Karina Fonseca-Azevedo and Suzana Herculano-Houzel demonstrated something remarkable when studying primate brains and diets. Raw food-eating primates hit a hard ceiling on how large their brains can grow, because their digestive systems simply cannot extract enough calories to support anything bigger. But once cooking enters the picture, that ceiling disappears. Suddenly, there's enough surplus energy to support a brain 3 times larger than would otherwise be possible. 3 times larger. Not because of some sudden genetic miracle, not because your ancestors simply willed themselves to be smarter, but because they discovered a way to unlock calories that were sitting right there in food the entire time. It's an uncomfortable thought, isn't it? That your ability to reason, to plan, to sit here and process this very sentence may trace back not to a leap in raw intelligence, but to something as ordinary as heat touching a piece of meat. But cooking didn't just reshape your brain, it reshaped your entire body. Anthropologist Katherine Zink studied exactly how much force is required to chew raw versus cooked food. Her research found that cooked meat requires dramatically less chewing force and fewer chewing cycles than raw meat. Multiply that difference across every meal, every day, for hundreds of thousands of years, and you begin to understand why human jaws became smaller, why human teeth became smaller, why the powerful jaw muscles that anchor to a heavy skull in other primates gradually reduced in humans, freeing up space for something else entirely, a larger brain case. Your gut changed too. Digesting raw, fibrous food requires a long, energy-hungry digestive tract. Cooked food needs far less processing, so over time, human intestines became shorter and less energetically demanding. That's more saved energy, more fuel available for a growing brain. It's a chain reaction. Cooking softens food. Softer food needs less chewing and less digestion. Less chewing and digestion frees up energy. That freed energy fuels a bigger brain. And a bigger brain eventually invents better tools, better cooking methods, and better ways to prepare food, which frees up even more energy. Round and round, reinforcing itself for 1,000,000 years. So what would have happened if none of this ever occurred? What if some early human population simply never discovered fire, or never thought to apply it to food? Based on what researchers understand about energy and brain growth, the answer is almost certainly this: you wouldn't exist. Not as you are now, A population without cooking would likely have remained locked at a much smaller brain size, similar to other great apes. Hours of each day would still be consumed by chewing. Complex language, abstract reasoning, long-term planning, all of these demand an energy budget that raw food simply cannot provide. There's a reason no other animal on Earth has built cities, written symphonies, or asked what it means to be conscious. It isn't because other animals lack curiosity. It's because none of them found a way to afford the energy cost of a mind like yours. And here's the part that should genuinely unsettle you. This wasn't planned. Nobody sat around a fire one night with the goal of eventually inventing philosophy or mathematics. Someone was simply hungry, and fire happened to be nearby. Evolution rewarded the accident, generation after generation, until an unplanned discovery became the foundation of human intelligence itself. Not every researcher agrees on the exact timeline. Evidence of controlled, habitual fire use is difficult to pin down in the archaeological record, and estimates for when cooking became widespread range from around 1 million to nearly 2 million years ago. The story is still being pieced together, fragment by fragment, campfire by ancient campfire. But the broader pattern holds. Something about your biology, your smaller jaw, your shorter gut, your energy-hungry brain was shaped by the simple act of applying heat to food. So think again about that last meal you ate, the warmth of it, the softness of it, the fact that you barely had to work to break it down. It feels ordinary, forgettable even, but it's the echo of a decision made by your ancestors hundreds of thousands of years ago, one that quietly rewired an entire species from the inside out. You are not thinking these thoughts in spite of your biology. You're thinking them because, long ago, someone chose to put food into fire.